Okay, so we went over some of this in class, but for those of you who are absent and for those of you who just want a little bit extra help, I'm going to go over the questions from the review. So, number 1, a steel ball is attached to a string and swung in a circular path as shown in the diagram below. If the string breaks when the ball reaches point P, which path will it most likely follow? Well, when an object is moving in a circle, at any given point, the velocity is tangent to the circle. So at any given point, if the velocity is tangent to the circle, if the string breaks, that's what's causing the centripetal force, that's what's causing it to move in a circle. So if that force is removed, it's going to travel in a straight line tangent to the circle. So the answer is B. Number 2, what does the phrase "with constant speed" mean, or even constant velocity mean in terms of Newton's laws? Newton's laws all deal with forces. And what that means is I want to know what does this "with constant velocity" mean in terms of forces. Well, if it has constant velocity, that means forces cancel and the net force F net is 0. So that's what that phrase means. Anytime you see "with constant speed," the bell should go off in your head that we're talking about a net force of 0. Number 3, what type of mathematical relationship is the law of universal gravitation? Well, since the law is F equals G times M1 times M2 divided by D squared, this D squared right there makes it an inverse square law. There are a lot of inverse square laws in physics. This is the first one with which we will be discussing. So there you go. Number next. What happens to the force of gravitational attraction between two objects if both objects double in mass and the distance between them is cut in half? Alright, let's look at this equation again. The law of universal gravitation says F equals big G times M1 times M2 divided by D squared. Well, since I'm talking about a relationship, this force versus this force, what happens to the force when I change something, I'm going to take that out of the equation, because the universal gravitational constant, big G, is the same no matter what. So I can take it out of the equation because I'm looking at a comparison. So in the first case, let's just say that M1 is 1, M2 is 1, and the distance between them is 1. So then I have 1 times 1 divided by 1 squared. So my force is 1. Now, in my second situation, what happens to that if I double both of my masses and cut my distance in half? Well, if the distance is cut in half, 1/2 squared is 1/4. So 2 times 2 is 4 divided by 1/4, and when you divide fractions, you multiply by the reciprocal, so that's 4 times 4, which is 16. Sorry, I was off the page. So, originally I was 1, I doubled both masses, cut the distance in half, and now it's 16. So that means the force is 16 times greater than it was. It kind of shows you what happens whenever you change the distance. It makes a really big difference in the force. That's that inverse square law in effect there. Okay, number 5, if a really big guy runs into a really small guy, compare the forces each guy experiences to each other. Well, Newton's third law tells us that equal and opposite forces, so the force that each experiences will be the same. The big guy is going to experience the same force as the small guy is going to experience the same force as the big guy. The difference is the effect of the force. The little guy, because he has less mass, is going to experience a greater acceleration, and that's because of Newton's second law equation, F equals ma. The forces are the same, but the masses are different, so therefore their accelerations will be different also. Number 6, what direction is centripetal force? Well, the word here kind of gives it away. Centri. Alright, centripetal force is always towards the center. That's why it's called centripetal force, center pointing force. Number 7, if you push with a constant horizontal force on an object, what does the object do if friction is ignored? Well, if friction is ignored, we have a situation where you have a unbalanced force, so the object will accelerate. Now, part B, if you push with a constant horizontal force on an object, what does the object do if friction is equal to the force you apply? If friction is equal to the force you apply, those cancel out, your net force is 0, so it's going to have a constant speed, just like the question number 2 here. Net force is 0 means constant speed. Number 8, if you were pushing on a box with a constant force, ignoring friction, what does the box do? Well, same thing it did in 7a, it accelerates, because it's an unbalanced force. Now number 9, if you suddenly stop pushing the box, what does it do? This same box from number 8, if you suddenly stop it, well, if we're ignoring friction, then once you remove the force acting on it, it's no longer going to have a net force. So the net force would be 0, so it's going to move at a constant speed. Number 10, if you do not ignore friction, what would your answer number 9 be? Alright, so if we're not ignoring friction, once you stop applying a force, then friction is going to be the unbalanced force, so it's going to accelerate. It's just going to be accelerating negatively, and it's going to slow down to a stop. Alright, does inertia have anything to do with how fast you're moving? No. Inertia is a property of matter that depends upon its mass. The more mass you have, the greater your inertia. So number 12, how is inertia related to mass? Well, if I increase my mass, I increase my inertia, so they are directly related. And that is it for what we did on class today. The next video will show what we're going to do on the next set of questions.